You're on this fantastic journey in learning chemistry. This video would teach you the concept of a mole in chemistry. Also, you will learn the meaning of Avogadro's number and molar mass. In chemistry, a mole is the fundamental unit of substance. It represents an unimaginably large number. 6.022 times 10 to the power of 23 objects, also known as Avogadro's number. To visualize this, 6.022 times 10 to the power of 23 bowling balls? Well, let me say it would cover an awfully big area the size of a planet. And the same way, 6.022 times 10 to the 23rd pennies would make you rich beyond your wildest dreams. Now, although the pile of bowling balls and the pile of pennies would have different masses or take different volumes, they are both 1 mole because they had the same quantity, 6.022 times 10 to the power of 23 units. What I'm trying to say is, a mole is just 6.022 times 10 to the power of 23 units of any substance. Now, to be real and focus on chemistry, let's look at a mole of water. You know that a water molecule is so small, I mean really small. And because water molecules are so tiny, a mole of water is only about 18 milliliters. We use different units depending on the substance. Atoms for elements like carbon, molecules for compounds like water, and formula units for ionic compounds like salt. Yet, 1 mole of anything contains exactly Avogadro's number, or 6.022 times 10 to the power of 23 units. Converting between moles and particles is a simple unit conversion problem. Let's say you got 10 moles of CO2, and without counting the CO2 molecules, you would just multiply 10 by Avogadro's number. Now, for an astounding chemistry fact, please listen carefully. If you take a quantity of mass equal to the atomic mass of an element expressed in grams, is the mass of exactly 1 mole. For example, the molar mass of copper is 63.546. So, if you take 63.546 grams of copper, the 63.546 grams will be a mole, because it would contain 6.022 times 10 to the power of 23 atoms of copper. For compounds, we take the sum of the atomic masses. To avoid errors, it's best to round molar masses to 2 decimal places. For MgNO32, we add the mass of 1 magnesium, 2 nitrogens, and 6 oxygens to get about 148.33 grams per mole. Now, you can weigh out a sample and know exactly how many molecules are on it, or how many moles it contains. If you found this helpful, please subscribe and press the thumbs up button so we can help even more students on this journey. I'll see you in the next video with more chemistry concepts.